6, exercise 6.1. The previous video we have seen all the theorems where triangles are involved. So now we'll go into exercise 6.1. Fill in the blanks using correct word given in the brackets. All circles are similar, because why we are telling similar is because if you are taking circles with different radius, they all will not be congruent. If you are taking same radius for different circles, then they are congruent. But if the size is different, shape is the same, size is different with different radius, then it is similar. All squares are dash. Now you can have the length of the square or the side of the square different. So here they are all similar figures, but the shape is the same. They are not congruent, they are not of the same length. If you tell all squares of same length are, means it is congruent. All squares are dash means it is similar. All dash triangles are similar. All equilateral triangles are similar. Two polygons of the same number of sides are similar if their corresponding angles are dash and their corresponding sides are dash. So two polygons are similar. We know that their corresponding angles should always be equal. If you are taking two triangles, size can be different, but they're proportional. The side should be proportional, corresponding side should be proportional, and the angle should be equal. Now give two different examples of pair of similar triangles, non-similar triangles. So here you are having similar triangles, means you are having two equilateral triangles, examples of two similar figures. So here two equilateral triangles, if I take, the size is different but the angles are same, 60, 60, 60. It is for equilateral triangle because for both the triangles it's equal, it's an equilateral triangle. Then this only the length is the side of the equilateral triangle is different. Next, you take two rectangles. Rectangles also, all the angles are 90 degrees. It's sum up to 360, but the length and breadth is different for both of them. But these two figures are said to be similar. Now examples of non-similar figures. Now comparing a triangle with a rhombus. Triangle is a three-sided polygon and rhombus is a four-sided polygon. So these two cannot be compared because you cannot have the angles. Some of the interior angles of both of them are also different. Okay, so therefore you cannot compare them. Now next, rectangle and trapezium. The sum of the interior angles is same here, 360, 360. But here two opposite sides are equal in a rectangle and all the angles are 90 degrees, but for whereas in a trapezium there can be two equal sides but they are non-parallel. Parallel sides are unequal. So this figure, you can see from this figure very well that there are two non-parallel sides and there are two parallel sides. Non-parallel sides can be equal. Non-parallel sides, the other two parallel sides are not equal. So therefore it cannot be a rectangle. Therefore these are not similar, non-similar figures. Now state whether the following quadrilaterals are similar or not. So now here we have two quadrilaterals. We'll just see what are the angles of these first. Corresponding angles of the two figures are different or unequal because you're having this, one is a square. In a square you know that all the angles are 30 degrees. The other one is a rhombus. So in a rhombus it is not necessary that all the angles are 90 degrees. So therefore these two are not similar figures. If the angles are same, then only you can tell both the figures are similar. Next, going into exercise 6.2 chapter 6. In the given figure 1 and 2, D is parallel to BC. Find EC in 1 and AD in 2. So now here what all are given information from this is given in triangle ABC, D is parallel to BC. So you are having AD by DB, that is AD by DB, that is 1.5 by 3 is equal to AE by EC, means AE by EC is this 1 by, you don't know what is EC, so I have just written as EC. So we are getting that EC is equal to 3 by 1.5, that is EC is equal to 2 centimeters. You can multiply with the 10 in the numerator and denominator. So you are going to get it as 30 by 15, which is equal to 2 centimeters. Next, so you found out what is EC in the first figure. In the second figure, what we have to find out? We have to find out what is AD. Again, we can use basic proportionality theorem. You know the triangle ABC, given in triangle ABC, B is parallel to D is parallel to BC in this also. So you can tell AD by DB is equal to AE by EC. The same thing you are taking. So now AD is given as 7.2. We have to find out what is the total. We have to find out what is BD here. AD is, which is 7.2. Okay, BD is 7.2, I think here. Yeah, BD is 7.2, not AD. So here you can take the AD by BD is equal to AE by EC. You can write it in that way. So you're going to get it as AE is nothing but 1.8 and EC is 5.4. So AD by 7.2 is equal to 1.8 by 5.4. So which is equal to, you can multiply with the 10 on both the sides or divide with the 10 also. So 18 by 10 you can write, or 18 into 10 you can divide in denominator, you can multiply it with 100. So now you are getting 24 by 10, therefore AD is equal to 2.4 centimeters. Next problem. E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR or not. So how do we do this problem? We'll see. So now the first one you're having, given PE is equal to 3.9, EQ is equal to 3 centimeters, PF is equal to 3.6 and FR is equal to 2.4. So now if we have from basic proportionality theorem, what do we have? If PE by EQ is equal to PF by ER, then we have EF is parallel to QR. So therefore now we can just check it using basic proportionality theorem. Having 3.9 divided by 3 is equal to 39 by 30, which is equal to, you're multiplying with the 10 on both sides. So therefore in the numerator and denominator, which is equal to 1.3. PF by FR is 3.6 by 2.4, multiply with the 10. So 36 by 24, which is equal to 3.3 by 2, which is equal to 1.5. So therefore 1.3 is not equal to 1.5. Therefore EF is not parallel to QR. And also you are having that PE by EQ is not equal to PF by FR. Therefore BF is not parallel to QR. EF, I'm sorry. Next, second problem in this, given PE is equal to 4 centimeters. From the figure you can see EQ is equal to 4.5 centimeters, PF is equal to 8 centimeters and FR is equal to 9 centimeters. So therefore by using basic proportionality theorem, we can check that PE by EQ is equal to PF by FR or not. So now we are first finding out what is PE by EQ or QE, which is equal to 4 by 4.5, 40 by 45, which is equal to 8 by 9, and PF by FR is equal to 8 by 9. So therefore you are getting here PE by QE, this ratio is equal to this ratio, that is PE by EQ is equal to PF by FR. So therefore EF is parallel to QR. This is according to basic proportionality theorem we have. Now next we have to check for this also. So given PQ is equal to 1 by 1.28, the whole thing, you can see the arrow marks from here, this part. This 1.8 is nothing but PQ, and PR is equal to 2.56 and PE is equal to 0.18, PF is equal to 2.5. So from one of the corollary you can see that EQ can be written as PQ minus of PE. So you're getting it as 1 by 1.10, and also you will get FR is equal to PR minus of PF. So which is equal to 2.56 minus of 0.36. This PF is nothing but 0.36. So therefore here you are getting it as 9 by 55, 9 by 55. PE by EQ is equal to PF by FR. After finding out, you can see both are equal, therefore EF is parallel to QR. Next, in the figure, if LM is parallel to CB and LN is parallel to CD, prove that AM by AB is equal to AN by AD. So now from the given, what is given from the figure? LM is parallel to CB. To prove AM by AB is equal to AN by AD. So now if you take two triangles over here, if you consider the two triangles by using basic proportionality theorem, we get that AM by AB is equal to AL by AC if you consider the triangle ABC. In triangle ABC, from basic proportionality theorem, you can write that AM by MB is equal to AL by AC. It is using one of the corollary, you can write this. Usually we will write AM by MB and AL by LC, but here you are writing it as AM by AB, which is one of the corollary. It is by basic proportionality theorem also. Now given that LN is parallel to CD, in triangle ADC, you have, by using basic proportionality theorem, you can write as AN by AD is equal to AL by AC. Now from 1 and 2, since both right hand side AL by AC we are having, we can equate both the left hand side, that is AM by AB is equal to AN by AD, which is the part which we had to prove, required to prove is that. So hence proved. Next, in the figure, D is parallel to AC and DF is parallel to AE. Prove that BF by FE is equal to BE by EC. We have to prove this. So now in order to prove this, what will we take is, we will first take in triangle ABC, given D is parallel to AC, so therefore you can prove that BF is, you have to prove that BF by FE is equal to BE by EC. So thus by using basic proportionality theorem, we can say that BD by DA is equal to BE by EC. If you are taking D is parallel, that is this part is parallel to this part, where I have written yellow color, these two are parallel, so therefore you can write BD by DA is equal to BE by EC. Okay. Next, in triangle BAE, if you are considering only this triangle, you are having DF is parallel to AE, so therefore you can write BD by DA is equal to BF by FE. Okay. So now you can take this as the first equation, which we have proved from a triangle ABC, and the other one which we proved with triangle BAE, we are taking that as the second part. So now in both of them we can see common. What is common? BD by DA is common. So equate the right hand side part on both sides. You are getting BE by EC is equal to BF by FE. Therefore this is what we had to prove. These two are equal because they are both are equal to BD by DA. Next, in the figure, fifth problem, in the figure, D is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. So now given that in triangle PQO, D is parallel to OE. Okay. So if D is parallel to OQ. So here you can see that from basic proportionality theorem, we can see PD by DO is equal to PE by EQ. So you can see here very clearly this part and this part by this part. Okay. When you are considering this triangle only, this topmost triangle. Now next, in the other triangle, that is POR, given in triangle POR, you have OF is parallel to, DF is parallel to OR. This is D over here in between. It is not O. So DF is parallel to OR. Therefore, by using basic proportionality theorem, you get that PD by DO is equal to PF by FR. This PF by FR, this is common for both. That is PD by DO is common for 1 and 2. So equating 1 and 2, you get P by EQ is equal to PF by FR. Therefore, by using converse of basic proportionality theorem, we have EF is parallel to QR. Therefore, EF is parallel to QR, hence proved. Now in the figure ABC, next problem, in the figure A, B and C are points on OP, OQ and OR respectively, such that AB is parallel to PQ, AC is parallel to PR, and we have to show that BC is parallel to QR. So now given in triangle OPQ, this triangle which we can consider all the red yellow color part, this in this triangle what we have is in OPQ, if you use, because you are having B is parallel to we are having that, using basic proportionality theorem, we get that OA by AP, because AB is parallel to PQ. Since AB is parallel to PQ, you can write OA by AP is equal to OB by BQ. Next, also given in triangle OPR, you are having AC is parallel to PR. Therefore, AO by AP is equal to OC by CR. So now again here you can see from 1 and 2 equating from equation 1 and equation 2, both are equal to OA by AP. Therefore, OB by BQ is equal to OC by CR. Therefore, by converse of this basic proportionality theorem in triangle OQR, BC is parallel to QR. Next, seventh one. Using basic proportionality theorem, prove that a line drawn through the midpoint of one side of a triangle parallel to other side bisects the third side. So now you are proving what you have to prove. You have to prove that it bisects the third side. If it is drawn from a line is drawn through the midpoint of one side of a triangle, one side it is drawn midpoint, and it's going to bisect the third side. So now how do we do this? What do we use in this? A triangle ABC, D is the midpoint of AB such that AD is equal to DB. A line parallel to BC intersects AC at E as shown in the figure above. In the above figure such that D is parallel to BC. We have to prove that E is the midpoint of AC. So now since D is the midpoint of AB, you have AD is equal to DB. And if AD is equal to DB, you can write it as AD by DB is equal to 1. You are dividing both the sides by DB. So you are getting it is equal to 1. So name it as equation 1. In triangle ABC, you also have D is parallel to BC. So by using basic proportionality theorem, you can get that AD by DB is equal to AE by EC. So that only I have written here. AD by DB is equal to AE by EC. But you know that AD by DB is equal to 1. So from equation 1 we can say that AE by EC is equal to 1. That means AE is equal to EC. Hence E is the midpoint of AC. Hence proved. Now eighth one. Using converse of basic proportionality theorem, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So now what is given? Given in triangle ABC, D and E are the midpoints. You are having here the figure. D and E are the midpoints of AB and AC respectively such that AD is equal to BD and AE is equal to EC. Now what you have to prove? You have to prove that of a third side is parallel to the third side. That is D is parallel to BC we have to prove. So now in order to prove that since D is the midpoint of AB, you have AD is equal to DB, and again if you divide by DB on both sides, AD by DB is equal to DB by DB, which is equal to 1. You can take this as equation 1. Next, also given E is the midpoint of AC, AE is equal to EC, which implies that AE by EC is also equal to 1. So from 1 and 2, equation 1 and 2 we get AD by BD is equal to AE by EC. Therefore, by converse of basic proportionality theorem, we can tell that D is parallel to BC. Hence proved. Now next, ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO by OB is equal to CO by OD. We have to show this. Now ABCD is a trapezium where AB is parallel to DC and diagonals AC and BD intersect each other at O. So now what we are doing, we have to prove that AO by BO is equal to CO by OD. Now from the point O, we are going to draw a line to E such that draw a line EO touching AD at E in such a way that EO is parallel to DC and also parallel to AB. Now in triangle ADC we have OE is parallel to DC. So therefore by basic proportionality theorem we can write AE by ED is equal to AO by OC. You can see that AE by EO is equal to AO by OC. So therefore now in triangle ABD, in the other part you have that EO is parallel to AB. So you can write it as D by AE is equal to, therefore you can write this here, OD by OB. OD by OB is equal to DE by EA by using basic proportionality theorem to ABD, since OE is parallel to AB. Therefore from equation 1 and equation 2 we get AO by CO is equal to BO by DO, which implies that AO by BO is equal to CO by DO. We are cross multiplying this BO, we are bringing down and we are taking CO the other side. So therefore getting it as AO by BO is equal to CO by DO, hence proved. Now the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. Now here a quadrilateral ABCD where AC and BD intersect each other at O such that AO by OB is equal to CO by OD. Okay, this is given to us. So now we have to prove that ABCD is a trapezium. Now from the point O, draw a line EO touching AD at E in such a way that EO is parallel to DC, it's also parallel to AB. So now in triangle DAB, by using, since EO is parallel to AB, by using basic proportionality theorem, DE by EA is equal to DO by OB. Also given that AO by OB is equal to CO by OD, which implies that AO by CO, you bring CO this side, when you cross multiplying you can get it as C. AO by BO is equal to CO by DO. So you are taking BO this side and bringing CO this side. So therefore it becomes AO by CO is equal to BO by DO, which implies that I can reverse it. So reversing, you are getting that CO by AO is equal to DO by BO, which implies that DO by OB is equal to CO by AO. So from equation 1 and equation 2 we get D by EA is equal to CO by AO. So by using converse of basic proportionality theorem, EO is parallel to DC. So therefore you can get here, and EO is parallel to AB, which implies that AB is parallel to DC. Hence quadrilateral ABCD is a trapezium. We have to prove that any two sides are parallel. So in order to prove that this DC is parallel, AB is parallel to DC, we have to show all this. So in order to show that, we use basic proportionality theorem. We made equation 1 and equation 2. So the following steps we followed, and then we got by using converse of basic proportionality, since EO is parallel to DC and EO is parallel to AB, which implies that AB is parallel to DC. Hence quadrilateral ABCD is a trapezium with AB parallel to CD. Hence proved.